Hello my dear children of class 11 science. Today again we do continue with the chapter, the new chapter that we had just started in the last class. We just did the introduction of this chapter, and that is thermodynamics. Okay, this is one of the important chapter under unit number 8. Okay, now in today's class we start this chapter with the terms used in thermodynamics. We try to understand and define some important terms that is used in what? Thermodynamics. Okay, because in the last class we just understood about what is the basic idea of thermodynamics, means what is the concept of thermodynamics. Okay, now we move now to the terms related to or used in what? Thermodynamics. So one of the first term that we need to understand and that we use in thermodynamics is the system. The first term is what? System. And children, this particular chapter, as I said already, is also very important in chemistry also. Okay, now even it is very important for further studies also. Now there is a first term that we need to understand, that is called system. And children, system is basically nothing but a fixed amount of matter. A fixed amount of matter, maybe it can be a solid, it can be liquid or gas. Okay, enclosed within a surface, enclosed within our surface in which we are concerned is actually called as system. Okay, like example, I take there is a vessel. Consider there is a vessel. Okay, and in this vessel there is a fixed amount of gas which is enclosed in a vessel. Suppose I consider there is a piston out here. Okay, there is a piston out here, and this piston encloses certain amount of gas. So there is a gas enclosed in a vessel. There is a gas enclosed in a vessel. So this is a gas, and this gas only acts as a system, because this gas acts as a matter which has a certain amount, a fixed amount, which is enclosed within this surface. This surface means like a vessel. This surface is like a what? Vessel, with the piston that is used. Okay, then this amount of matter, the fixed amount of matter, okay, that is gas, okay, act as a system. Okay, act as a what? System. But not necessarily it can be a gas only, it can be a liquid, it can be solid, or it can be others. Okay, so this is called system. So in thermodynamics, children, our attention is always focused on the system. Okay, our attention is always focused on the system. Now the next term that we need to define, that is number 2. Okay, I'll mark that number 2. It's called surrounding. That is called surrounding. So I'm writing surrounding. Now what is surrounding? And children, surrounding can be defined as everything outside the system. Everything outside the system under consideration is called surrounding. Okay, and this surrounding may have the direct what effect on the what performance of system. Okay, and this is called surrounding. Like example, let me take this diagram. So this gas is a system, and this vessel, it can be made up of what? Conducting vessel, or it can be a non-conducting vessel, is a surrounding. Okay, because out of system, okay, it's called surrounding. Okay, this is like a boundary. This is like a boundary. Okay, which separate, which enclose the what? The gas, that is gas as a system. And this vessel, it can be made up of what? Any vessel. Okay, can be a surrounding. Okay, because if it is a conducting vessel, then it has an impact on this gas that is on the system. If it is a non-conducting vessel, then it also has some impact on the system, and that is called surrounding. Okay, so this is number 2. Now we have number 3. So number 3 term that we need to define is, so children, basically isolated system is one of the terms that we need to define now, or use in what? Thermodynamics. Okay, now isolated, now you know the word isolated means which has nothing to do with outside. Okay, so in case of thermodynamics, the isolated system is that system, okay, in which there is no exchange of what? Matter and even a what? Energy with any other body, or we can also use the word system. Okay, and that system is called isolated system. So let me just write the statement out here. Okay, in the manner like, if the surrounding, okay, let me just use the word, if the surrounding, okay, if the surrounding of a system, if the surrounding of a system does not does not have what? Does not have any effect on the system. Does not have any effect on the what? System. Okay, then it is called, this particular system is called isolated system. It's called isolated what? System. Okay, now as I said already, isolated system cannot exchange matter or energy with the system, with the other system or with the surrounding. Okay, means this system, let me write down, this system does not what? Exchange matter or what? Energy. Means there is no exchange of heat as a form of energy between the system and the surrounding, and there is no exchange of matter, okay, between the system and surrounding, and that system is called isolated system. Means there is nothing to do this system with the surrounding. Okay, so this type of system is called isolated system. Okay, so this is number 3. Now we go to the next system term after the isolated system, and this term is actually called as thermodynamic coordinates. And thermodynamic coordinates are basically the physical quantities. These are the physical quantities which are used to specify the state of the system, and these coordinates are called thermodynamic coordinates. Okay, so let me just add the point. The physical quantity, these are all the what quantity? These are the physical quantities. Okay, these are the physical quantities, okay, which are used to specify, which are used to what? Specify, which are used to specify the system. Okay, these are used to what? Specify the system. Okay, and used to specify the state of the system. Specify the state. Let me use the word, the state of the system. State of the what? System. And these physical quantities are called what? Thermodynamic coordinates are called, let me just write, are called thermodynamic coordinates. Okay, thermodynamic what? Coordinates. And children, for the most important part under thermodynamic coordinates is using these coordinates, means these physical quantities, we can find the internal energy of the system. So you need to understand about the internal energy, okay, that I'll teach in other videos. Okay, but using thermodynamic coordinates we can define the internal energy of the what? System. Okay, now just to give the example of thermodynamic coordinates, like in gases, let me take the example of gases. In case of gases, okay, the thermodynamic coordinates are nothing but the pressure. Yes, the pressure of the gas, the volume of the gas, the temperature. So these are all the physical quantities, okay, that specify the state of this gas as a system, and that is called thermodynamic coordinates. Like pressure of a gas, the volume of a gas, the temperature of a gas, even the composition. Okay, let me use the word composition. The amount. Okay, so these are all what? Thermodynamic coordinates in case of what? Gas. Because gas as a system, and this physical quantity act as a coordinates, thermodynamic coordinates. Similarly, I'll take the example in case of liquid. Another thermodynamic system, or simply called as system. In case of liquid, okay, like they are the physical quantity which can define as density, and you have learned about surface tension. Every liquid has surface tension. Okay, even temperature. Just example I'm giving. There are other physical quantity also, but these are the example of what? Thermodynamic coordinate that specify the state of the system. The state of system means like the liquid as a system. Okay, and these physical quantities are called thermodynamic coordinates. Now children, we go to the next term to define, that is called thermodynamic system. So let me just write out a thermodynamic system. So the next term that we define and try to understand is called thermodynamic system. Now thermodynamic system is simply a system which can be described by using thermodynamic coordinates. See, thermodynamic coordinates we have already learned. Okay, so if thermodynamic coordinate is used, okay, to express a system, and that system is called thermodynamic system. So just add a point, a system, okay, which can be described, system which can be what, described by using what, using thermodynamic, okay, coordinates are called, okay, is called, let me use the word, is called what, thermodynamic system. This is simply called as thermodynamic system. So this is another term that we define under what, thermodynamics. Okay, now thermodynamic system can be expressed by the coordinates, and you know coordinates we have learned already about, like pressure, volume, temperature, density. Okay, it is for liquid as well as gas also. Okay, so these are surface tension, these are all the coordinates which are called thermodynamic coordinates, and this thermodynamic coordinate specify or describe the system, okay, and that system is called thermodynamic system. And for the example, gas as a thermodynamic system, because gas is characterized as specified by this pressure, volume, temperature. These are what, thermodynamic system. Liquid also a thermodynamic system, and solid can also be considered as thermodynamic system. Okay, so this is another term that we learned. Now children, we go to the next term, that is number 6, which is called equation of state. Now this concept of equation of state is also very important in one of the unit, that is unit number 9, the kinetic theory of gases. Okay, but as for the thermodynamic topic is concerned, okay, the equation of state, okay, is actually nothing but the relation. This is nothing but the relation between pressure, which is marked by letter P, volume marked by letter B, and temperature, which is marked by letter what, T. And this pressure, volume, temperature are also called what, thermodynamics coordinate, or also called variable, okay, which determine or specify the thermodynamics what, system. And this pressure, volume, and temperature, okay, can be expressed by a relation, and this relation is called the equation of state. Now the equation of state is expressed by the relation PB equals to nRT. I am writing a relation right now, okay, and you will derive this relation also in one of the chapter called kinetic theory of gas. Okay, PB equals to nRT. Now this equation, okay, is called a perfect gas equation. This equation is also called as what, equation perfect. So I am using the word perfect, or also called as ideal gas equation. Ideal what, gas equation. So gas as a thermodynamic system expressed by this variable pressure, volume, temperature, and this variable can be expressed by the relation, and this relation or equation is called equation of state. Okay, so pressure, volume, and temperature expressed by the relation, but the relation is PB equals to nRT. So in the relation, this N is actually called the number of moles. This is actually called the number of what, moles of a gas. And you have learned, children, in details in class 10 the mole concept, the term moles at all you have learned already. Okay, and R is actually a constant, and you learn this constant as a universal gas constant. This is usually called as universal gas constant. Gas what, constant. Okay, so this equation or relation is actually called as equation of what, state. So this is number 6 term. Now we have a last term to define, and that is number 7. And number 7 term is actually nothing but thermal equilibrium. So we try to understand what, thermal equilibrium. Okay, we try to understand the term known as what, thermal equilibrium. And children, you have an idea about thermal equilibrium. Thermal means heat. Okay, equilibrium means equal. Okay, means what is thermal equilibrium is actually defined and expressed by one of the physical quantity that is called temperature. Because you know temperature is that physical quantity that measures the degree of hotness or coldness of a body. Yes, the degree of hotness or coldness of a body is determined by the physical quantity called what? Temperature. Okay, that's why if there are two bodies, let me just take, there are two bodies, one is body A and there is another body what? B. Okay, now on touching the body side A, if this body A appears higher, hotter, if the body A is hotter, and body B is what? Colder. Just giving the example, colder. Okay. Now we understand that this body A is, which is hotter, means at higher temperature. This is at what temperature? Higher temperature. And this body which we feel colder as what temperature? Lower temperature. Lower temperature. Okay, lower what? Temperature. So we are taking two bodies. One is body A, another body B, in which body A appears hotter than body B, are placed in contact. Suppose if they are placed in contact, then definitely what happened? There is a heat which flow from body A to body B. You have learned it already, because the heat always flow from body at higher temperature to a body at what? Low temperature. Okay. Now, and after sometimes you know that they appears equally hot. They appear equally hot, means they maintain equal temperature. That means both the body A and B equal temperature. So that both the bodies acquire same temperature. Okay, under this consideration, by means they are keeping in contact with each other, then we say that body A and B are said to be in what? Thermal equilibrium with each other. Now thermal equilibrium means the system of bodies, okay, when they are kept in contact at different temperature, then heat flows from a body at higher temperature to a body at low temperature till both the body acquire same temperature. And when both the body acquire same temperature, then we say that two bodies are in thermal equilibrium with each other. Now the word thermal actually related to the heat and the amount of heat, okay, the hotness or coldness of bodies measured by the temperature. But if the system of bodies acquire same temperature on keep in contact with each other, or mixing each other, then we understand that that bodies are in thermal equilibrium with each other. So these are the important terms that I have explained in details, children, for thermodynamics. Now there are other term or important topic that we need to learn in from this chapter, and that is basically Jirath Law of Thermodynamics, and that you learn in the next YouTube video.